This is my strategies for mystery numbers for week 16. These are actually my favorite ones because they take a lot of problem solving and thinking, so I think they're kind of fun. So the first thing we're going to do is look for the largest three-digit number where the product of the digits is 72. So remember, product means multiply. So when I'm putting these numbers together, I get the number 72. So sometimes I just start with doing like 3 times 9 is 27. 9 times 1 is 27. So I know no combination of 1, 9, and 3 are going to get me 72. So I can eliminate those. So then I just go to the next 3. 9 times 1 is 9. 9 times 8 is 72. So I know that I'm dealing with 9, 1, and 8 now. And so if I want the largest three-digit number, which number would I want in the hundreds place? I would want 9. Then I would want 8 in the tens place, and then 1 in the ones place. Now, because of the commutative property, it doesn't matter that I'm now multiplying 9 times 8 times 1, because no matter what order I multiply 9, 1, and 8 in, 8, 1, 9, or 1, 8, 9, I'm going to get 72. So as soon as I figure out those are the three numbers that get me 72, then I can arrange them to be the largest possible number there. So now this one says the largest number less than 900 that is a multiple of 3. So that tells me I cannot have a 9 in the hundreds place here. So that's either going to be an 8, 1, or 3. Multiples of 3, I always do the digital root where I add together the digits until I get a single digit that is either a 3, 6, or a 9. So again, same process as this one up here. I just kind of do trial and error. If I were to put an 8 in here, and then a 9, and then a 3, that's the biggest number I could do. Now let's check to see if it's a multiple of 3. 8 plus 9 is 17. 17 plus 3 is 20. 2 plus 0 is 2, not 3, 6, or 9. So I know that that is not an option. So it was really close, so I'm going to take this 3 off and see what happens if I put a 1 in there. So if I have, because again, I'm trying to find the largest number. I know the 9 can't be in the hundreds place, so let's try this one. 8 plus 9 again is 17. 17 plus 1 is 18. 1 plus 8 is 9. So that tells me this could divide by 3. So just to show you that it does, if I do 891 divided by 3 here, I get a 2, 6, 29. That would be a 9 here, 27. 27 minus 9 is 2. Bring down the 1, 21. That would be 297. So 891 is divisible by 3. The key to these is that digital root, adding those digits together to see if you get a 3, 6, or 9 when you get it down to a single digit. So our next one, the three-digit number less than 300, that is a factor of 732. Ooh, that's a tricky one. But the fact that it has to be less than 300 tells me that I'm putting a 1 here because that's my only option. So now a factor of 732. So basically, let me think how I would solve this. Okay, so I know that I need to multiply two things together, so I'm going to put the 732 here, and then I'm going to divide it, and I'm going to try to get 100 something in here. So I know that I need 100, so I know that something needs to be like a 6 or a 7 here. So I'm going to try 6. So 1 times 6 is 6. Wait, that won't work. Well, so I get a 1 and a 3. So then I put a 2 here. So 12. So I get 122, but I can't put 122 in here because those aren't my options for my digit. So let's go back and try it as what if I did it divided by 7? Actually, I don't want to do a 7 because that was 122. A 7's going to be like 100 something, and I don't think it'll go in evenly, ending in a 2. So now I'm thinking, okay, what would end in a 2? And 9 would be too big, so we can't use that. 5 is not going to work, so I'm going to try a 4 here. So if I try 4, that would give me a 1 here, 4. Then I have 33 here. So that gives me an 8 up here. That's still working with my numbers that I'm noticing here. As soon as I notice I get a number that wouldn't work, I can quit working. But since the 8's there, that would work. So then I get a 32. Oh, I think this one's going to work. So 1 and then the 12. That would give me the 3 right there. So that tells me that this is going to be 183. So I use my inverse operations and kind of a guess and check, but with some properties in mind. I'm not going to divide it by 5 because I know that doesn't go evenly. So I narrow some things down to try to help me to get that extra number right there. So then, like I said, this is fun stuff. Lots of problem solving and thinking I have to go through. And hopefully you do too. So our last one here, the number between 800 and 900 that is divisible by both 3 and 7. So if it's between 800 and 900, I know that it has to have an 8 here. Then, again, if it's divisible by 3, I know that it needs to add up to be a 3, 6, or a 9. So I already know that that's right here. 891 is divisible by 7. Then I need to think about what 7s could end in. 7's not going to end in a 9. It's not going to end in a 3. It could end in a 1. And I don't think it can end in an 8. So I think my best number would be 891 again. But I would test it just to make sure. So here's a 1. 7, that would be 19. This would be a 2. Nope, that's not going to work, is it? Darn it. So sometimes I try to do a shortcut and it doesn't work out, so that's all right. I just have to go back to the drawing board and keep thinking. So now I'm thinking, what if I were to replace that 9, because that was the part that was the trouble, with the 3 instead. So if I put a 3 in here, first of all, does it still add up to a 3, 6, or 9? 8 plus 3 would be 11. And then 1 more is 12. 1 plus 2 is 3. So that works for my, it would be divisible by 3. So now let's see if it's divisible by 7. So we have the 1 here, 7, that gives us 13. So then we have 1 here. Darn it, that doesn't work either. What about... So, what about if we tried a 9 in there? Because I don't feel like we have tried that yet. Sorry, I had some technical difficulties and had to come back and it erased all my stuff. So we were going to try a 9. So we had 8, 3, and then we were going to try a 9. 8 plus 3 is 11. 11 plus 9 is 20. 2 plus 0 is 2. So that won't work because we have a, it won't end in a 3, 6, or 9 as a digital root. So 839 is not divisible by 3. So... what if we tried a 1 in here instead? Because 1 plus 9 is 10, 10 plus 8 is 18, 1 plus 8 is 9. I also know that something could end in a 9 because 7 times 7 is 49. So let's see what happens if I check 819 divided by 7. That gives me a 1 here. That's a 1 and a 1, so that would be a 1, 7 here. Whoops, moved my screen. 11 minus 7 would give me a 4. Oh, look, and there's that 9 that I talked about. So 819 divided by 117 does get us the right answer. So again, making these combinations of making sure that it adds up the digital root of these 3-digit numbers, adds up to a 3, 6, or 9, and then testing them with that 7 and kind of problem solving, thinking about what numbers can it end in and divide by 7. So that is your, what is this one called? Mystery number, I think, page.